Who should you trust more when it comes to USB serial numbers, Windows or Linux? In this video, we will look at obtaining the serial numbers from USB-connected media devices. Please help me out by hitting the subscribe button and ride into the danger zone. It used to be fairly straightforward to obtain the serial number of a USB-connected device. In Windows, you would just go to the registry and then look for the USB store, and you'll be shown the serial number, or told that the device does not have a serial number. Now that we have all kinds of USB devices, from thumb drives to externally attached drives to portable SSDs, they all behave kind of differently, so there isn't a real simple way to get the information you need. Let's start with a traditional USB thumb drive. In this case, we are using a OCZ Rally USB 2 thumb drive. Once we plug it into the system, Windows will record the information into the system hive under Control Set, enum, and then USB store, and then under the make and model of the drive. And we see here that in the USB store key, we have an entry for the OCZ Rally, which has 20 plus thumb drives, and then we have this other one that only has one. So these are all the OCZ Rallies that I've plugged in to this Windows machine in the past. And when we click onto the proper device, we see that the serial number displayed. And for this particular drive, we see that it's 993794B3. A second method that we can use on a Windows machine is to look at the diagnostic event log. And the way you get to the viewer is to launch the event viewer. And then from there, you look under Microsoft, Windows, Partition, and then the diagnostic.event. And so once we're here, we can also see the same serial number reported, 993794B3. A third method we can use is to launch a command window first by just simply going to the start bar and then typing CMD. And then from here, we can use the WMIC command, the Windows Management Instrumentation command line. And then we can get the information for the drive. In particular, we are interested in the model, serial number, and then the device ID. So we're going to go ahead and type WMIC disk drive, and then get model, comma, serial number, comma, and then PNP device ID. So as we see here from the WMIC results, it lists out all of the disk drives that it sees, along with the model name, and then the serial number, and something called the PNP device ID, which is the plug and play device ID. And so if we look under OCZ Rally model, we get the serial number 993794B3. A fourth method we can use is to launch a PowerShell window. And then we're going to use the get disk commandlet to get the information for the disks that are visible to the operating system. And in particular, we're interested in the disk number and then the serial number. So we're going to go ahead and type get-disk, and we're going to pipe that into select disk number, comma, serial number. And then we are interested in disk number 2. So once we look across there, we see the serial number of being 993794B3. So for this OCZ Rally USB thumb drive, we see that all 4 tools come back with the same result. So this is great. All right, now we're going to go ahead and switch over to our Linux system running Kane. And on the Linux system, we can use the lsusb command to go get more detailed information about a USB device. So the first thing we need to do is just run lsusb by itself to list out all of the available devices. So we're going to go ahead and do lsusb. And then we can be specific with the device that we are interested in. So in this case, we're going to type lsusb -V for verbose, which gives us all the details. And then we're also going to use option -S to show the specific device. And in this case, we can see that our device that we're interested in is bus number 1, device number 11. So we're going to put 1:11, and then we're going to pipe that through more because it's a lot of data to read through and we just need the first couple lines. Note that we actually get no serial number here, and that's because I forgot to use the sudo for this command. So make sure we rerun this with sudo, otherwise we won't get the result that we need. So right now we can see that the serial number is reported as 993794B3. All right, the second Linux tool we're going to use is dmesg to look at the system log. So in this case, I'm only interested in the last 15 or so lines because I just plugged in the thumb drive and I know that the information is going to be the very last thing in this log. So I'm going to type dmesg, pipe it through tail-15. And what we see here is the serial number listed out, which matches the serial number that lsusb gave us. And it also matches the serial number from all 4 Windows methods. All right, now we're going to take a look at another brand of USB thumb drives. And this is going to be the Leef Supra, which is a USB 3 device. So in Windows, let's take a look at the registry under the USB store. In this case, we are using a Leef Supra. So as we scan down, we can see here that the serial number for the device is listed as 04113100001076 All right, so next let's take a look at the diagnostic events log. And we'll do a refresh. And once we found the right entry in the log, we see that the serial number is reported as AA, a whole bunch of zeros, and then 489. Which is different than what's in the registry. And I have noticed this exact serial number being reported by other tools using other media devices. So it's clearly something meaningful, but not the real serial number. And I just don't know what it is. So if you know, please go ahead and put that in the comments below. All right, so let's move on to the third Windows tool and see what WMIC gives us. And here we see that for the serial number, it reports AA, a bunch of zeros, and 489. And then for the field of the plug and play device ID, it gives us that number of 0411310000010762, which matches what's in the registry. So that's good. So now let's take a look at our fourth Windows tool, which is the get disk commandlet in PowerShell. And again, for disk number 2, we see serial number is AA, a whole bunch of zeros, and then 489 again. So for this Leef Supra USB 3 thumb drive, we see that the 4 tools gives us 2 different results. And it's kind of disturbing because I don't know which one is the real serial number. So let's see what Linux gives us. On my Kane Linux box, I am going to use the lsusb command to find the bus and device number. And we see here that the bus and device numbers are 2 and 2. So let's go ahead and put that into the lsusb command to get the full details. So lsusb-v-s2:2 and pipe it through more. And once again, I forgot to do the sudo, so we got nothing useful. Let's do that again with the sudo. Sudo lsusb-v-s2:2, pipe it through more. And now we see the serial number of 0411310000010762. So that's a good thing. And let's go ahead and use dmesg to see what the system saw as the serial number. So dmesg, pipe it through tail-15. And we see the make and model serial number listed here. And it looks like the serial number is identical to what we saw earlier with lsusb. So my conclusion for this device is that the two Linux commands gave us the correct serial number, as did the Windows registry and the WMIC in Windows. Now we're going to use a SSD connected to our system via a SATA to USB cable. And the hard drive I'm using is going to be a Sandisk X300 SSD. In Windows, let's take a look at the registry in the system hive. And this time, instead of looking at the USB store, we're going to look under the SCSI section because these SSDs adhere to the SCSI protocols as opposed to the USB protocol. So they will appear in this other section. And what we see here for a serial number is 7 ampersand 39 AC 7A10 ampersand 0 ampersand 0000. And from way back when I learned register forensics, I recall that if there is an ampersand in the second character, that means that the connected device actually does not have a serial number, and this is just the number that Windows assigns it. And that is very sus because I know for sure there is a serial number because it's printed on this drive. Well, let's move on. Let's take a look at the diagnostics event log. And we're going to do a refresh. And once we found the right entry in the log, we see that the serial number here is reported as 187B9765431, which is different than what's in the registry. And if your hunch is that this does not look like a serial number, you're probably right. It's not the serial number printed on the SSD itself. So what is it? Well, it's probably the identifier to the SATA USB cable, as it seems to be fairly unique as I looked at a few of these cables I have, and they all gave me a unique number. And this is the same behavior if I used a drive dock instead of the SATA to USB cable. So it appears that any of these connectors will report its own serial number instead of the drive's serial number. Well, let's see what WMIC gives us. So in the DOS window, I'm going to go ahead and just up arrow to the command that we've used before. And here we see that the serial number it reports is that same 187B9765431 number. And then interestingly enough, in the field for the plug-and-play device ID, it gives us that 7 ampersand 39 AC 7A10 ampersand, so on. So it matches the registry. Well, let's look at what getDisk commandlet gives us. And it looks like it gives the 187B9765431 as the serial number. So basically for the Sandisk X300 SSD, we see that the tools give us differing results and none of which match what's printed on the drive. Not making me very comfortable, but let's see whether Linux can give us the right answers. Using the lsusb command, we see that the bus and device numbers are 2 and 6. So let's put that into the lsusb command, sudo lsusb-v-s2:6. And I'm going to pipe it through less. And here we see the serial number of 1234567 which is backwards from what Windows reported to us. That's interesting. Now let's use dmesg, pipe it through tail-15, and once again we see that odd looking serial number which is identical to what we saw in lsusb, and so I'm pretty confident this is the serial number for the SATA to USB cable. And because we're looking at a hard drive, let's use the hdparm tool to view the information on that drive. So I'm going to do sudo hdparm -I of /dev/sdd and pipe it through less. Now we see the serial number of 152008400007, which matches what's printed on the drive. So that's encouraging. Let's take a look at the next tool, which is Smart Controller. So I'm going to do sudo smartctl -a of /dev/sdd. And once again, I'm going to pipe that to less. And we see the serial number of 15200840007, which matches the output of hdparm. So the conclusion here is that lsusb and dmesg are grabbing the serial number of the connector, just like the Windows tools. But hdparm and Smart Controller seem to be going behind the connector and grabbing the actual serial number from the device itself. So I think we have pretty good conclusive proof that those wacky numbers are the connectors. Let's look at another SSD device. This time it's an external device with a built-in USB port. So in Windows, when we look at the registry, once again, we're going to look for the SCSI key instead of USB store because these SSDs adhere to the SCSI protocols. So what we see here is the serial number of 6°6D18DFD ampersand and so forth. And so once again, it does not look right. And then it also has the ampersand in the second character. So it looks like it's a Windows assigned identifier. But let's see what the other tools come back with. So now we're going to take a look at the diagnostic event log. And once we've got the right entry, we see that the serial number reported here is 20207Q4000986, which is different than what's in the registry, but this is the same serial number printed on the device. So I'm pretty sure this is the right serial number. Let's take a look at what WMIC gives us. So once again, in the DOS window, I'm just going to go up arrow. And what this reports back is that same 2020-7Q4000986, which again is the serial number printed on the drive itself. And interestingly enough, in the field for the plug and play device ID, it gives us the 6°6D18DFD number, which is in the registry. So lastly, let's take a look at the get-disk commandlet from PowerShell. And the serial number reported here, once again, is the correct 2020-7Q4000986 number. For this Sandisk Extreme Portable SSD, the event log, WMIC, and get-disk gave us the correct serial number. So let's see what Linux gives us for this device. Using the lsusb command, we see that the bus and device numbers are 2 and 7. So let's go ahead and put that into the lsusb command with sudo lsusb-v-s set to :7, pipe that through less. And here we see the serial number stated as 3230, 3230, 375134, etc., etc. And even though this looks like a serial number, this is not the number printed on the drive itself. And I have no idea what this identifier is, because this actually did not appear in any of the Windows tools. So next, let's take a look at dmesg to see what the system saw as a serial number. And this time I'm going to use a tail of 20 instead of 15 because there's a little more information from this drive. So dmesg pipe tail -20. And if we scroll up a little bit, we will see the same long serial number that starts with 323032, etc. And again, because we're looking at a hard drive, let's go ahead and use the hdparm tool to review the information on that drive. So doing sudo hdparm-I of /dev/sdd and piping through less, we see the serial number of 20146E802374. which looks like a serial number, but it does not match what's printed on the drive. So these tools have given me two numbers which are not what I'm expecting. So let's see if we have any luck with smartctl. So sudo smartctl-a of /dev pipe it through less. And we are greeted with an error that says that it has encountered an unknown USB bridge and wants us to specify a device type with the -d option. Okay, I can follow simple instructions. And then I'm going to run smartctl again, this time with the -d option. And then I'm going to specify a SCSI drive. So sudo smartctl-a-d SCSI /dev/sdd piping through less. And this time we are greeted with the serial number of 2020 7Q4 00986, which is the one etched onto the drive. So let's go back to hdparm, which gave us a weird number. Because we specified SCSI when we ran smartctl, let's use the cousin to hdparm, which is sdparm, for SCSI disks. And I'm going to go ahead and specify sudo sdparm --page equals sn /dev/sdd. And the --page option allows us to specify what information we want returned. And SN is for serial number. So what we get back is the serial number of 2020 7Q4 00986, which matches the output of smartctl. So the conclusion for this Sandisk Extreme device is that lsusb and dmesg are showing some numbers which is not the serial number. hdparm itself does not work properly on this device, as it's classified as a SCSI device as opposed to a SATA device, so we had to use sdparm. And once we realize that this drive is being treated as a SCSI device, using sdparm and smartctl with the SCSI option properly grabs the correct serial number. Oh boy, so what's the conclusion after looking at all these different types of drives? Looking at this table that summarizes our findings for the various types of USB devices we tested, there is no clear winner in terms of one tool that consistently gives the right answer. In this chart, a green check represents that the tool correctly reported the serial number. A red X means it gave the wrong information. The word PNP means that the serial number is given as the PNP device ID field. And lastly, the fishy means that in these instances of using a drive dock or SATA to USB cable, the serial number reported is that of the connector device instead of the actual media device. So that's why it's a little fishy. So on the Windows front, WMIC seems to be the most consistent tool that gets what we believe to be the serial number. On the Linux front, lsusb and dmesg will properly report thumb drive info. And the hdparm, sdparm, and smartctl commands will properly report hard drive serial numbers. So whatever your OS of choice, just be aware of these differences in behavior when you use the tools, and be careful what you write in your forensic reports as the serial numbers. For more videos on Windows forensics, see these videos here. For more videos on the Linux command line, watch these videos here. Make sure you click on the blue monkey to subscribe. Thanks for your time and happy hunting.